Okay, so we are going to move into the next unit, kicking things off with triangles. And first we start off with classifying triangles. So what the different kinds of triangles are, and identifying the parts of those triangles, and doing some basic problem solving. So some vocabulary that we should already be familiar with. A triangle is a three-sided polygon. The corners or the points of the triangle are called vertices. Each vertex is an angle, and we have the sides of the triangle that are formed by segments. The three angles inside a triangle will always add to 180 degrees. So that's a really important rule or property of triangles. The three angles will always add to 180 degrees. Next, we talk about the kinds of triangles or classifying these triangles. And we can classify triangles based on their angle measurements or their side measurements. And there's a relationship between the two. So we always want to be as complete as possible. So let's look at a few definitions here. An acute triangle is a triangle that has three acute angles. A right triangle is a triangle that has one right angle. We can see it right here. And the other two angles have to total 90. So they have to be complementary. Remember, if all three angles add to 90, our right angles, all three angles add to 180, our right angle is already 90. So the other two together have to make up the other 90. Um, so the two acute angles in that right triangle will always be complementary. An obtuse triangle just means that it has one obtuse angle. The other two will always be acute. And we have this thing called an equiangular triangle. Equiangular, which really just means equal angle. So an equiangular triangle has three angles that are all equal. And if you think about that, when the angles have to total 180, if all three angles are congruent, they're all going to be 60 degrees. So classifying based on angles. We can also classify angles based on their sides. A scalene triangle, all three sides are different. In an isosceles triangle, two sides are the same. Now, the technical definition, at least two sides are the same. But if all three sides are the same, meaning all three sides are congruent, we have a better name, equilateral triangle. Okay. And there is a very consistent relationship within triangles, meaning if all three sides were congruent, all three angles are congruent. And this is, it's bidirectional, meaning it works both ways. If we know all three sides are congruent, that guarantees all three angles are congruent. And vice versa. If we know all three angles, if we know it's equiangular, then that means it will also be equilateral. If two angles are the same, two sides are the same. And if no angles are the same, meaning all of the angles are different, then all the sides are different. Scalene. So we want to keep in mind these relationships because that's going to help us a lot as we work with triangles. Okay. So the first few things we're asked to do here is just classify the triangle based on its angles and its sides, again, as best as we can. So one thing we notice right away, I'm just going to make this a little bit bigger here. In number one, notice the markings of the sides. They're all marked different. That's suggesting to us that they have different measurements, so this is scalene. The next thing I want to do is look at the angles, and they only gave us two, but we can figure out the missing angle because we know that all three angles of a triangle will always add to 180. So that means the missing angle here is 50. So if we look at our three angles, they're all different. Well, that supports the idea all three sides are different. So it's scalene. But more specifically, they're all acute. So we would call this an acute scalene triangle. Usually the angle word comes first. If we look at number two, we can see that this is a right, and then we can say isosceles. Now remember, in an isosceles triangle, two sides are the same, but it also means two angles will be the same. And we're going to talk more about isosceles triangles in a few minutes. In number 3, it is shown to us that it is equiangular. All three angles are congruent, which means all three sides are the same. So it is also equilateral. Now, again, we can say it's an acute because all three angles have to measure 60, but equiangular covers that already. In number 4, look at the angle. We clearly have an obtuse triangle. And looking at the sides, we can also say scalene. In number 5, those two sides of the triangle are marked as congruent. So we definitely have an isosceles. And, well, it looks acute, but we don't have any numbers. So, if they start throwing in numbers and variables, we might find out that is acute, or maybe it's obtuse and it's just not drawn well. It's not drawn accurately. The only thing we know for sure is that it's isosceles. And in number 6, well, we're given two angles and we can look at it, but we really should do the work. Don't just assume. Find the missing angle. I mean, if you know the rule, all three angles will always add to 180, and you're given two of the angles, then find the angle. Don't guess, don't assume, find the missing angle. And if we do our work here, that's an 85, which means our missing angle is 95 degrees. So this is actually an obtuse triangle. I know a lot of us are going to look at that and say, oh, it looks like a right triangle, and it looks it, but we can't see that it's 95 versus 90. So we have to do the work, and we find out it's obtuse. We could also say it's scalene, because if all three angles are different, then all three sides are different. So we have an obtuse scalene. Now, with some of these triangles, there's some special vocabulary that comes with them. And some of it we've already covered. Like in a right triangle, we know that that side is called the hypotenuse. The other two are called the legs, right? We know that from Pythagorean theorem. A squared plus B squared equals C squared. So we already know the hypotenuse and the legs. Right? But we have to know this because when the question says, in a triangle, the hypotenuse, they're already telling us it's a right triangle. So we can already draw it and fill in some information. And again, keep in mind that since it's a right triangle, the two acute angles will always be complementary. So vocabulary very specific to a right triangle. We also have some vocabulary that is very specific to an isosceles triangle. In an isosceles triangle, we also have legs, but the legs are congruent. The third side is called the base. On the base sits base angles, and those base angles are congruent. Remember, if we have two sides that are congruent, we must have two angles that are congruent. Well, there they are. So on the base sits the base angles. The third angle, happens to be at the top in this picture, but it does not have to be. It's called the vertex angle. The base and the vertex are always opposite of each other. So if you draw an arrow out of that vertex angle, it's going to point to the base. This idea of angles and sides that are opposite of each other is really important because there's relationships in these angles and sides. So again, just some vocabulary, and we have to be familiar with it. In an isosceles triangle, there are two sides that are congruent. They're called legs. There are two angles that are congruent. They're called base angles. They sit on the base. And it has nothing to do with top or bottom. The picture can be rotated. So if I took our picture and I rotated it, and I indicate those are the base angles, well, then these are the congruent legs. So it's all about the parts of the picture. Everything in geometry focuses on the parts of the picture. And before we go any farther, we should also talk about how to name a triangle. Any polygon gets named by starting with one vertex, one corner of the shape, and going around it, either clockwise or counterclockwise. So, for example, we can start at A and then go clockwise, B, C. So, triangle ABC. But I could have started at A and went the other way and call it triangle ACB. It's the same triangle. We choose one vertex and then go right around it, naming the other vertices in order. It's not about alphabetical order, it's about the order that they are in the picture. And with a triangle, you almost can't go wrong. We have to be really more, a lot more careful when we get to other shapes. But really, really, really important, notice the triangle indicator in front of it, the little icon. That is really important. Without that, we wouldn't know if we were talking about just 3 points, the plane, the angle, the arc, the whole triangle. Remember, an angle has measurement, but a triangle has 3 different angle measurements, 3 different side measurements, perimeter, area, altitude. It has a lot of things. So we have to know what we're talking about. The whole shape, the triangle, or maybe just angle ABC. Maybe just angle CBA. There's just angle BCA. There's 3 different angles. So we always have to know what we're talking about, whether it's the angle of the triangle or the whole triangle. And this comes back to marking period 1, naming things and knowing and being able to find them in the picture and knowing what they are. Angle versus segment versus triangle, which has 3 angles and 3 segments. Really important. And again, the idea of angles and sides that are opposite of each other. So if we said, angle A in this picture, I'm just going to highlight it here, angle A, draw an arrow out of it and it points to the opposite side. Now, in your mind, I want you to think about if I took that angle and opened it more, made it 120 degrees or 130 degrees or 170 degrees, the side opposite, BC, would have to get longer to keep it a triangle. Right? Again, if I took this angle and made it go like this, I open the angle, the opposite side would also have to be longer. So there's a relationship between angles and sides that are opposite of each other. And we have to be able to identify which angles and sides are opposite of each other. So very simply, we can draw an arrow coming out of it. It's not that tough. If we're talking about angle B, draw an arrow coming out of angle B, and it points to the opposite side, AC. The relationship between angles and sides that are opposite of each other is very important, and we have to be able to identify those. So we're being asked to do a little practice here. And let's run through it and see where we stand. First of all, we're given some information that should not be overlooked. If we're given information, it is really important. So let's just talk here. AD is equal to BD or congruent to BD, right? So AD and BD. Well, that's important because that means we have an isosceles triangle. You can't overlook that information. We're given DC is perpendicular to BC. Well, they meet at C. So that's telling us where the lines are perpendicular, and we know perpendicular lines make right angles. So now we have a right triangle. So we can see in this picture we have 2 different triangles that are connected to each other. We have an isosceles triangle, and we have a right triangle. That's everything so far. Let's try to answer a few questions. So we're asked to name an acute triangle from this picture. Now, again, without having numbers, we're going based on what it looks like. But one of them is a right triangle. So it's not that one. It has to be the isosceles triangle. So I'm going to call it triangle ADB. Triangle ADB. Again, we could have used those 3 points in any order. So there are 6 correct ways of writing it. ADB, I just want to make that neater. ADB. But make sure you have the triangle symbol in front of it. ADB, ABD, BDA. You just can't use the point C. It's not part of that triangle. We're asked to identify the hypotenuse. Well, again, vocabulary. Only a right triangle has the hypotenuse. The hypotenuse is opposite the right angle. So it's segment BD. You could call it BD or DB, but it is that segment. Stay within that triangle and name that part appropriately. The vertex angle. Well, think about it. The vertex angle. Only an isosceles triangle has something called the vertex angle. In an isosceles triangle, so we know we're talking about the isosceles triangle in this picture, triangle ADB. There are 2 base angles that are congruent, and then there's the vertex angle. So this is just the vocabulary. If you're not sure, scroll back, rewind. We have to know this vocabulary. So the vertex angle is the angle that connects the 2 legs of an isosceles triangle. So in this case, it's angle ADB. Angle ADB. Notice the difference between number 1 and number 3. In number 1, we were asked to name the whole triangle. And in number 3, we're being asked to name just that angle. Even though it's the same letters in the same order, they mean completely different things. And of course, we could have reversed it and called it angle BDA. Well, we also just did number 7. So since we already have it in the picture and we're already talking about it, we might as well fill it in. The base angles. Well, one of the base angles I could call angle A because it's the only angle there. But the other one I have to use 3 letters. So I'm going to call it, I don't know, ABD. Again, this all goes back to marking period 1, naming an angle. So if that's something that requires a little, review, then you can check out some of the other videos or, make sure that you go back and review those kinds of things. Okay. Back to number 4, complementary angles. So we're looking for 2 angles that will add to 90 degrees. Well, without any numbers here, we've got to do a little thinking. We do have a right triangle. So this angle is already 90, which means the other 2 in that triangle have to add to 90 also. So notice how I marked them. 1 arc, 2 arcs. I'm not saying that they're congruent. I'm identifying 2 different angles, but I am guaranteed that they add to 90. So angle CDB and angle CBD. Be very careful with your letters here. The base, well, let me just fill that right angle back in. The base, well, only an isosceles triangle has a side that is called the base. The legs are congruent. The last side is called the base, so it is AB. This is purely vocabulary, but it's vocabulary that we have to become very familiar with. The right angle, well, the right angle here can very clearly be identified as angle C. And again, we could use 3 letters, but it's okay to use 1 letter in this picture because there's only one angle at point C. Number 8, the legs of the isosceles triangle. Well, we already marked them off. That was the first thing we did here. It's segments AD and BD. AD and BD. And number 9, the side opposite angle DBC. Well, again, we have to find it. So DBC. Trace the letters in order. DBC. And we want the side opposite it. So I'm just going to draw an arrow coming out of it, and it's going to point to it. So it's DC. Segment DC. And number 10, the angle opposite AD. So again, I want to find AD. AD is that side. So I'm going to stay inside that triangle. And I'm going to point to the opposite angle. So we might call it angle DBA. We have to be able to name these parts very carefully, very clearly, without hesitation.